Hi, it's Mr. Anderson, and this is AP Physics Essentials Video 50. It's on impulse, which is simply the product of the force being applied times the time over which that force is being applied. And so let me give you a scenario. Imagine we have a baseball here that's moving from the left towards the right, and so it has momentum towards the batter. And let's say he hits it. Well, what's going to happen to the momentum? It's going to change dramatically. It's going to go in the opposite direction. What's causing that, however, is the impulse. The bat is applying a force over a given period of time. And what's interesting is that the change in the momentum and the impulse are equivalent. What does that mean? They're always going to give you the same value, and that makes them really valuable when we're looking at physics. And so let's look at two spheres that are being dropped on a table. Let's imagine that they both fall with the same velocity and they both have the same mass. So watch what happens to the first one and then the second one. And so a good question might be, which has experienced the most dramatic change in momentum? That's kind of a trick question. Since they both have the same mass and the same velocity, and at the end they're at rest, they've experienced the same change in momentum. Therefore, their impulse is the same. And so what's different in these two spheres as they fall to the table? Well, it's the time over which they interact with the table itself. The one on the right is really slowing down over a longer period of time. And that means it's applying less force to that table. And so momentum will change over time. And so if we have these two spheres, the momentum is going to be the same between each of those. The impulse is also going to be the same. What's the impulse? It's simply multiplying the force of an object times the time of that object. And these are equivalent. The change in momentum and the impulse are exactly the same thing. And so what's different in these two spheres? Well, in this sphere right here, what we're getting is a really large force over a short period of time. And this one, we're getting a really short or a small force over a long period of time. And that fact is so important that it could literally save your life. Cars have gotten safer and safer over time. And so this is a safety video. If we were to crash a 57 Chevy, an old car, into a wall at 35 miles an hour, the person inside would really be hurt because it's going to come to a stop almost instantaneously. But watch what happens when this Honda Civic is driven into a wall at 35 miles an hour. Again, it's slowed down, but watch how long it takes for that car to come to rest. And so it's like that squishy ball. It's taking a longer period of time for it to change its momentum. And so we're decreasing the force experienced by both the car and the person inside the car. And so to figure out how these two are related, it's really simple. And it begins, like everything in physics, with Newton's second law, which is force equal to mass times acceleration. But let's break down acceleration, which is simply going to be the change in velocity over time. Now I'm going to take both sides of this equation and I'm going to multiply them times time. And so if I do that, what do I get? The two subjects of this video. Momentum change, which is mass times the change in velocity. That's on the right. What's on the left? That's going to be the impulse. And these are equivalent, so we can use it to solve really difficult problems. Like, could you calculate the impulse and the force on both the car as it crashes into the wall and then the crash test dummy on the inside of the wall? Well, you'll be able to, and we'll work through a few problems like that. And so if you want to figure out what we need to solve a problem like that, it's all given in the equations up here. Mass times change in velocity, force times time. But we're just watching a video here, so you don't see any force in the video. And so we're going to have to solve for that in a little bit of an indirect kind of a way. And so what would be the first things that we could figure out? Well, we got to figure out the mass. And so I could just give you the mass. The mass of this car, which is a 2013 Honda Civic Hybrid, is 1,301 kilograms. And the mass of the person inside the car is around 78 kilograms. What else could I tell you? Well, we know this car is going at 35 miles an hour, and at the end, it's going to be going 0. And so we could see a change in velocity of 15.6 meters per second. What else do we have to figure out? Well, it'd be important for us to figure out time. This information right here is enough for us to figure out the momentum change and the impulse. But if we want to get at the force being applied to the car and the crash test dummy, we also have to know the time. And so let's watch the video and let me show you how you can figure this out. So we've got the car crashing into the wall. I'm going to grab the video right here. And you can see here that right at this point, at time 0, it's impacting the car. And we've reset our time to 0. And so what I want you to do is let's watch a section of the car. Let's watch this section of the car right here. And let's see how long it takes for that car to come to rest. And so again, we'll go back to 0. So it's now at 0. So we're at 0 here. And so just watch the car and figure out how long it takes for that car to completely come to rest. So let me keep moving. So right about there. So right about there, the car has stopped moving. And so we could say that that change in time is 0.072 seconds. I'm getting that right here. But if I keep playing the video, you'll see that that person continues to move. They're still moving forward, and they don't come to a stop until around here. And so we could say their time of impulse is going to be 0.112 seconds. And so let me give you a simple problem. What I want you to figure out is calculate the impulse and the force being applied to both the car and the man sitting within the car. And what I would encourage you to do is pause the video right here. You have everything you need right up here. I would grab a piece of paper and try to work this out. Again, you're going to have 4 values when you're done. Impulse of the car, force on the car, impulse on the man, force on the man. And so pause the video, try to work that out, but I'm going to show you how to do it right now. And so what you would do if we're trying to figure out the impulse on the car, all you need is the mass of the car and then that change in velocity. And so impulse is equal to the mass times the change in velocity. So I'm simply putting in the mass right here of 1,301 kilograms, the change in velocity of 15.6 meters per second. And so my impulse is going to be this, newtons per second. Now, how did I get that? Well, since it's a force times the time, it's going to be newtons times seconds. You can see here that this number has way too many significant digits, and so I could reduce that so that it has 3 significant digits, and that's the answer of the impulse on that car. Now, how do we figure out the force being applied? Well, since I showed you the time, 0.072 seconds, if we want to figure out the impulse, all we do is simply divide by the time. So if we divide it by the time, it's going to give us the force that's being applied. So I'm going to take that impulse, which is right here. I'm going to include all those significant digits. And then I'm going to divide it by the time, which is 0.072 seconds. It's going to give me a force of that. And then, again, too many significant digits, I can figure out my force, which is only going to have 2 significant digits. And so it's going to be 2.8 times 10 to the 5th newtons. Why is that? Because 0.72 only has 2 significant digits. And so that's a massive force that's being applied to that car. But since the time is greater than it would be with an old car, it's actually going to be a much smaller force you would experience in a new age car. Let's say we were looking at the person inside it. How do we figure that out again? Again, you could stop right now, and if you want to try to solve this one, you sure could. We're going to start with the impulse, which is simply going to be the mass times the change in velocity. And so I could figure it out like that. With significant digits, it's going to be 1.2 times 10 to the 3rd newton seconds. That's going to be the impulse. If I want to figure out the force, all I'm going to do is going to be to divide by the time. And so that's going to give me a value of around 1.1 times 10 to the 4th newtons. And so that's going to be the force that is applied to that person. Now that's not a deadly force, and the reason why is that we've increased that amount of time. Even though the momentum and the impulse stay the same, by increasing the time we can decrease the force. And so did you learn to justify the selection of data if you want to figure out the impulse or if you want to figure out the force? And then finally, could you predict, analyze, and design a plan for collecting data? In this case, we used a video to look at the change in that momentum over time, but you could use a ticker tape, you could use a motion sensor to figure this out. So that's impulse, again, product of force times time, and I hope that was helpful.